Hey guys, welcome to 7.3's notes completion via video, proving that quadrilateral is a p-gram. So parallelograms so special, they get two separate sections in our textbook, pretty standard in all geometry textbooks, because there's a lot of things going on inside a parallelogram. And basically this section is the converse, a lot of converses of what we learned last section. So last section it was if it's a parallelogram, then the opposite sides are congruent. And you see here, we flip the tracks. If both pairs of opposite sides of quadrilateral are congruent, then it's a p-gram. So we just switch the order, the converse, if you will. Right? Same thing with opposite angles. Converse of the opposite angles, converse of the opposite sides. So there's two ways to show something's a parallelogram. And that's really what this section is all about. We want to use the properties we just learned last section to determine or prove that a quadrilateral is a p-gram. All right, so now check it out. They're asking you some stuff here. They're going to draw up a scenario in quadrilateral ABCD. So let's sketch it out. And again, just go in order. You can start your A anywhere you want, any vertex, as long as you go in A, B, C, D order with which they write it. And let's mark it up. They're saying that AB equals BC, so AB equals BC, and CD equals AD. Is ABCD a parallelogram? All right, well now, we know that we need the opposite sides to be congruent for it to be a parallelogram, and we don't have that now. We have the consecutive sides. So you'd have to say a big old no on this one. And the reasoning would be that we do not have opposite sides congruent. Opposite is the key thing you got to have. Because really what this could have looked like, I'll just draw it down here, then I'll erase it. It could be a kite, right? You could have those two the same and those two the same. So not a parallelogram unless you have the opposite sides congruent, as the French would say. It's like, I don't know what the French word is for congruent, but I'm sure it's really cool. All right, second example. For what values of x and y is the quadrilateral a parallelogram? So just like last section, they would have said, hey, this is a p-gram, solve for x and y. Now we're saying what values of x and y make it a p-gram. So what are you allowed to do here? Well, opposite sides have to be congruent for this to be a parallelogram. So I would set, let's see, if we go left and right, we have y equals x. We have y and x in the same equation. So I'm going to look for the path of least resistance. So if you can find x's in your equation and solely x's, then that's where you should start. So we can take x plus 9 equals 2x minus 1. So solve this for x. Let's see, let's subtract x on both sides, add 1 to both sides. So x equals 10. And then we can plug that back in to solve for y. So y equals 10 plus 7, or 17. All right? Bada bing. Moving along, two more theorems. A couple other ways to show that you have the opposite sides and opposite sides both parallel and congruent to show that it's a parallelogram. If one pair, the same pair, it's got to be the same pair of opposite sides are both congruent and parallel, then you have a parallelogram. So that's a new one. We didn't really talk about that last section. Didn't apply last section, but now it does. This one, however, did apply. Parallelogram diagonals converse. So we know that if we had a parallelogram and the diagonals bisected each other, the converse is also true. So that's a way to determine parallelogramism as well. So a very important section on the next quiz will be right here. Are you dealing with a parallelogram or not? So I'll have a quadrilateral, I'll have it marked up, and you use what you know about parallelograms to determine whether or not it works. So let's see, this first one. Oh boy, this is a tricker. It wants the same pair of sides to be both parallel and congruent. This, we have a pair of parallel sides here, and the congruents are there. So that is no good. That does not fit any of our criteria. Because really, this could look like this. It could be an isosceles trapezoid. Those could be congruent and those could be parallel, not a parallelogram. Stick to your rules if you forget. Stick to your theorems. Now this one's awesome. Straight up, opposite angles are congruent. You need both pairs. Both pairs of opposite angles are congruent, so that's a yes. Now down here, C, this is good. The same pair of opposite sides are both congruent and parallel, so that's a yes. That's a weird looking yes up there. Sorry about that. This pen is tough to write with. And, okay, D, awesome. This is exactly what our formula, or what our theorem tells us. The diagonals are indeed bisecting each other, just like the theorem says, so there's a yes. So again, we'll have a section on the quiz just like this. We'll practice more in class, of course. All right, more properties of parallelograms. Finding diagonal lengths of a parallelogram. For what value of x makes it a parallelogram? So to be a parallelogram, of course, diagonals have to bisect each other. So of course, NE is the same as CN, and FN would have to be the same as ND. So we can take 5x minus 8 and set it equal to 3x. So subtract 3x, get 2x, add 8 to both sides, and x is 4. So that's the value of x that would make the quadrilateral a parallelogram. All right, stop the video here. Try the monitoring progress question below. All right, and back again. For what values of x and y make it a parallelogram? So remember, parallelograms have a couple different things with the angles. We can look at the consecutive ones equaling 180, or the ones across from each other equaling each other. So use your head. Where are the x's, where are the y's? Since my x's are across from each other and my y's are across from each other, I want to use that rule. Don't make it too hard and put these two equal to 180, then these two. No, don't do that. Stick with the path of least resistance. Look for your x's, look for your y's. Where are they? And in this example, they are across from each other. So set the angles across from each other equal to each other. Subtract x on both sides, add 32, so x is 32. And then for the y values, again, they're across from each other. Set them equal to each other. So 3y is 87. And 3 goes into 87 29 times. So there we go, my friends. X and y that would make it a parallelogram. All right, on this page, this summarizes all the ways to prove a quadrilateral is a parallelogram. So by definition, opposite sides are parallel. Then here's our 4 theorems we learned. Opposite sides are congruent. Opposite angles are congruent. The same pair of sides are both parallel and congruent. The diagonals bisect each other. There you go. All right, last thing we're going to do in this section, using the coordinate plane. Identifying a parallelogram in the coordinate plane. Show that the quadrilateral ABCD is a parallelogram. So now, we got any of these ways will work. The easiest way is to show that the opposite sides are parallel. How do we do that using coordinates? What comes back? Of course, our slope. If we can show the opposite sides are parallel, then that's this first thing here. By definition, it's a parallelogram. You could show the same pair of sides are both opposite and congruent, and parallel and congruent. You could show the parallel, or you could show that both sides are congruent using the distance formula. But the slope formula, probably the easiest way. So that's how we'll do it. So let's check. Let's check the slope of AB. Slope of AB, 5 minus 3. Remember, it's rise over run. So the y value's on top. 5 minus 3, 2 minus a minus 3 is 2 plus 3 on the bottom. So 2/5. So the slope of AB is 2/5. So now let's check CD. CD's slope, 2 minus 0 on top of 5 minus 0. So far we got one pair of sides, opposite sides parallel. That's awesome. Now let's check the other pair. Let's check and see if those are parallel. So AD, the slope of AD. All right, let's go. Doesn't matter which way you go. 3 minus 0. The y value is on top. Negative 3 minus 0. So 3 over negative 3 is negative 1. Now let's check BC. BC's slope, 5 minus 2 on top of 2 minus 5. So 3 over negative 3 again, negative 1. So since those are the same and those were the same, you've got yourself a p-gram. So this is a show me using slope, or like I said, you could do distance. Check the opposite sides are congruent using the distance formula. That would work as well. All right, pause the video here, try this last one, see what you guys come up with. All right, I'm back again. Let's check our slopes. So KL, the slope of KL. It didn't graph it for me, so I got to put the points in. So this point is 2, 3. And this point over here is -2, -3, -4, 1. All right, so the slope, 3 minus 1 on top of 2 plus 4. So I have 2 over 6. So 2, 6. Now I'm checking that with JM. JM. All right, what do we got here? 3, 1, 2, 3. So 3, -3 is the point M. And then J is -2, -3, 1, 2, 3, 4, 5. So -3, -5. All right, so -3 plus 5. That's my change in Y. And over top of 3 plus 3. So that is 2 over 6. So those are looking good. They're parallel. Now let's check KJ. So KJ's slope. Let's go like this. 1 minus a minus 5 is 1 plus 5 on top of -4 plus 3. So I have 6 over -1, so -6. And we'll check LM to wrap things up here today. So I've got 3 plus 3 on top of 2 minus 3 is again 6 over -1, -6. So these two are the same. Bada bing, bada boom. Parallelogram. Yes, all good. All right, guys, that's 7-3. Peace.